Information sharing. The last two videos I did was on information sharing, the problems we have, kind of an overview of how we're going to attack the problem. And then this one is the assistant, which is how we're going to actually accomplish this. So I'll give you a brief detail of how information should be shared. Right now we have no ability to share any information. And I'll explain that, hopefully. I explained that a little bit in the last two videos, but this one, it'll get a little bit more detailed. So first we need to know what I mean by information sharing. Okay. What exactly is information and what do I mean by sharing? For one is that a simple transform of data is not information sharing. If there's any documentation required, any human involvement required, that's not sharing information. That's putting it in some format that you document and stick out there. So information sharing, we want to be able to share data and logic. Logic is information too, so our data structures and everything else. So who do we want to share this with? We want to share it with the operating system, other applications. We'd like to share data with ourselves. So if we write an application, it may have a couple or 100 subsystems. And each of those subsystems need to share information between each other with no effort. Right now we call functions and hopefully we can find and read documentation or go look for the source codes. That's not information sharing. That is brute force movement of information from one value to another. And we'd like information sharing with our hardware devices. We'd like to know, we'd like the assistant, our compiler, our assistant, I prefer the word assistant, our computer assistant, to already know how to do this. And the only way that can be done is if the hardware device tells the assistant exactly what can be performed, how it to perform it, and what structure it's in. So if I'm talking to the hardware, the CPU, I'd like to know all the relevant information about the bit structure of an integer, or a floating point number, or a date, or any other value. Exactly how many bits, where's bit 1, what's the order of bits, are they, don't say swap because you don't know what swap means. Is it swap from my system or swap from their system, or it doesn't mean anything. But we need to know exactly what the integer is, what it can represent, what operations are possible, and so on. So even from the CPU hardware, we need to know the instruction sets. That's information sharing, so that we don't have to worry about your application. The hardware is an application. Okay, so we want to do it with hardware devices, and then we want to do it with other applications. Meaning we have multiple processes and multiple threads and multiple cores and multiple hardware, multiple computers. We'd like to be able to share information between all digital information on our disk drives. So we want access to every bit in the universe, literally, and have access by the assistant to bring that, like the cook, to bring that information in when I say I need to know how many monitors are on my system. I didn't ask for anything else, just tell me 2. I don't need documentation to ask that. Okay. So for the assistant, the job description is to store and retrieve and organize all information in logic, so that the information is designed for logic. We don't do that now. A good example is our text documents. They're all upper and lower case. We can't really search those. Okay? Not without either lowercase and everything or upper. It's not really designed for logic. Searching, okay? What we prefer is be able to look at a document and say, does this document reference cattle, frogs? Then we can search our databases extremely quick, and any of our documents or any of our information structures, they should be indexed for searching, because that's the most prevalent logic that we do, is search. And so if I'm sharing information, let's say with England on my parts of a car or something, and they say, well, yeah, send it to me, but also send an index, then the assistant says, okay, I will package that up, put it in my little box for you, send it to you, and when you get it, all you do is open it like it was in your application. You have the same functionality, the same exact knowledge that my application has for my purpose, so that if you want to send it back to me, you need to know what I will accept. The numbers have to be between 1 and 34. This is the lookup table, so I have to send you all that information. So there's a lot that happens in information sharing besides just, oh, here's a CSV with no names. Even if you have names, it's no value to you. You don't know all the things that I've set up in my system, but you need that if you're going to share it. Now, if it's a one-way share, you just want my information, you're not going to update it. My sister just wrote a book, a book publisher, and they couldn't even they couldn't keep their edits. For some reason, they'd get lost or intermixed or, So there's a lot, they wanted to share the editing of a book. It took them a year, probably, I don't know how many phone calls just to get this thing. They did a digital book, and then they produced a hard copy. It was a joke. And these were the publishers that had the software. So this is really what I'm talking about. All knowledge, all purposes, all operations for information sharing. And the two main reasons we cannot share information is intentional. All night, I don't know hardly any, very few companies publish the format of their information. Not really. They may give you some values, but you don't know what those values are, why they're, what are they. They put all that hard-coded logic within their little application. So we want to get all that information out of the application into the information, if it's important for that information, like the code tables and the qualifiers. This is a whole number, 0 to infinity. This is a counting number, 1 to infinity. This is a negative number, this is a positive number. So all of these things, this has a range. This is, this represents the height and width, and all that knowledge has to go with it, because we're trying to share that knowledge that we have. And the second reason is our stupid logic, our compilers don't do anything. So we have compilers that their only way to get information in and out of their application is, the easiest way is just to do memory to memory, memory to disk, and back in. But that memory to anybody else is just a block of bits. There's all that real knowledge is in the application. So we want to optimize this for sharing. And that's what the assistant's job is to ensure that every piece of information that an application creates is shareable with itself, because it needs to be able to load and unload information without loss of intelligence. It means that when I send it out there, I want to be able to load it back in without any work from that. Right now, if I write any kind of application, it's a nightmare trying to get data in and out of my own application in a way that, well, for one big thing I want is forward and backward compatibility. So if I write it last year and I read it back in this year, and I've added fields and changed formats, that all has to be accounted for. So how do we overcome these issues? Well, first, we should not use certain products that you can only share with another Word application. And so that's what we need. Excel and all these other products, billions of basically every product out there, if we can't really share information with, it only understands its own process. But every application within the assistant, it knows all the logic. So it's going to build those applications for you. But we'll get to that at another video. Anyway, we get to a point where you just let the assistant do it. Don't let it organize the information. Let it optimize for sharing, so that we separate character styles from the characters themselves. So we don't have upper and lower case explicitly. We have a character A and it's lowercase or uppercase. That way we can always search. We can be dependent or independent of case, style, color, underlining, font, all these characteristics that we could use for information sharing. Oh, the blue ones are my values, the red ones are your values. So we can use a lot of, create information that has logic in it so that we can actually share knowledge between the human. And so exactly how are we going to do this? How is the assistant actually going to, somewhat, I'm going to be kind of vague here because there's a lot more to it. But the main thing is we want to create technologies. Means that any piece of information, we want to be able to handle all aspects of that particular data structure. That integer. Okay. We really want to be able to qualify and classify every piece of knowledge that we know about an integer that we have in our application. How many bits? Okay. I'd like to go to a variable length, so we want variable length numbers and fixed length numbers for our hardware. Our hardware has forced us into this stupid fixed length binary structures, which is stupid. We really need to go to variable length, but we want both. That's what I'm saying. We want to create technology that will handle both. So we can have a trillion digit number. Doesn't matter. Some computers do this. We might as well take advantage of it, not be forced into our hardware concepts of what a number is. Okay, so we create a technology. So if you have a good example of a technology in my mind is SQL. SQL is a single language, very concise, that manages can represent a table in any form. It can add columns, it can take columns out, it can calculate columns, it can filter out rows, and all within a SQL, and we can create rows with a create statement. So this little language of 5 or 6, keep adding more stupid language statements to it, to SQL. But the concept here is that, in my mind, it needs to be fixed, of course. I don't know why it's order dependent. There's a lot of questions I have on why we have 15 billion different SQL statement syntaxes. That's information sharing. We need to be able to share our logic too. And we can't do it when everybody changes every little thing that, oh, I don't like the way they did comments. I'll do my comments with a pound sign, or I'll do mine with a whatever. So anyway, but we need to move to create technologies that are not affected by other people. We let the assistant do this for us. So actually when you create an application, and we're doing this accumulatively. So when we create an application, it's done for everybody. Okay, we need, like I said, forward and backward compatibility. It means that when I create an application today, I'm going to share it with myself in the future. So information sharing, like I said, is with myself and my logic. So I may have logic that was done 40 years ago. I'd like to use it again. We have enough space now. I mean, before we had a 5 1/4 floppy and a 3 1/2 floppy, and that was pretty much our world. So we let the assistant do all the work for us of information retrieval, storage, optimization, and organization. And that you can do fairly easy. We already know how to do all these things. We want to remove all format dependencies, do that for you. So if you want access to Fortran and compile it, Basically, any information is information. You know, Fortran or Cobalt or C or Python or any of these things are just simply commands that you're asking the computer to perform. Compiling those into other types of commands so that the hardware can run it or can be emulated is still just an application. And we want to be able to share those applications, the source code of Excel or any application of an operating system. You know. So we want to be able to do that. And we want to remove all size limitations. Like I said, we want to go to a variable length numbering system. Jane managed the manipulation of logic. Because 99% of these are just numbers. Oh, well, make it 10, make it 12, make it 13. Anyway, so we want to be able to do that. And we want to perform all I/O. Basically, we want to perform all access to the hardware for you. You can still do it. I'm not limiting anything we're doing now. I'm just saying if we want to share data, this is the approach that I'm going to take. And we want partitions, which is the optimization of information for access, for sharing. And partitioning is one of the most important, which we don't have. And finally, we want to remove all external dependencies. But once you have a dependency on this format has to stay this way, we need to move. We have to have progress. And the only way we can have progress is if everything is changeable. That's why I want that forward and backward compatibility. You know? But we don't want to be dependent upon our current technology, like the format of our executable or our fonts or our keyboard or any of these existing technologies are really not designed for anything except a particular application. So I'm trying to remove all these dependencies like databases, our file systems, which is security, like to remove all external dependencies on any kind of security. We're going to go about 1,000 times more secure. Anyway, I won't get into security, but we need it at the hardware and the software level. That's where we have to go. And if I'm a bank, I don't know if I'm going to trust anybody. Client server technologies. No two applications can communicate, can share information. You say, oh, well, we do that all the time. No, we really don't. What you do is you say, okay, I'm an email. You're going to put it in this format. You're not sharing the knowledge. All you're doing is where that information came from. But they are not sharing information. They are forcing you into a particular structure, which has no value to anybody else except our stupid mail servers. So we want to be able to get rid of those. Compilers, you know, we want to not be dependent upon a particular language. We should have access to all languages because they're all the same. Editors, we'd like editors that is actually optimized for knowledge. Mathematics, physics, chemistry, dance, music, you know, baseball players, whatever. And our editors now are so specialized, and you know, so we want one all-powerful editor that shares information with the user. Here's the mathematic equation. You want to run it, you want to evaluate it, you want to reduce it, you know, which is sharing information with our logic, which is really what we're trying to accomplish. So that, and have the human be familiar with his own technology. Look, mathematics is thousands of years old, and yet we can't represent it in our computers. And we really don't want support by the assistant for application-specific information structures like HTML. They wrote this application, they keep kludging it up for all the different variations, but we have no way to actually use that information. HTML is only written for Chrome, no other system, or Apple, or IBM. But a lot of these systems have just said, look, Chrome, if you just do it, we can't follow your tail and keep trying to figure out what the heck you're going to do next. We really need to share our information with, like HTML, it's a form, right? It's simply a form. We'd like to use that for other purposes. We have forms everywhere. Everything, we don't need application-specific information. We want to remove all dependencies on our operating system, our bootstraps, and our hardware instruction set. So the thing here is this is kind of a very detailed, how do I, Cliff, going to write this? I'm writing it now, it's all hopefully just about done. But this is what we're trying to accomplish. I spent 25 years getting people out of the proprietary mapping systems. The vendors, no vendor, except IBM, would allow people to extract their own information. When I first started work, my big thing was I went to my first conference and the guy says, here's a mapping system. I like graphics, and so here's a mapping system. I said, well, what's the format? And he said, that's proprietary. It's my information. It's your information when you type a document. You should have access to that information. Right now we don't. We don't have access to anything. Our database, we don't have really access to it. They decide, oh, well, we'll give you this. We will, MySQL has 42 data types, which I have no idea exactly how to use those. Sure, the only way I could actually know is to set it up, put the examples in, and then see if that applies to my application. So we're bending our logic to fit all of these billions of isolated applications and data structures that are not really optimized for anything. This is where I want to go, is pure knowledge sharing. All right. Well, thank you very much. Have a great one. Bye now.